Alright, so this is the start of lesson 9.1. So the first thing you'll see is you have four different series of numbers, and I want you to figure out what the pattern is. So right now I want you to pause this video on some notebook paper. I need you to figure out what the pattern is, and then once you think you have all the patterns, push play, and then I'll go over what the answers are. Okay, so let's see if you got them right. The first one, I have 1, 1, 2, 3, 5, and 8. So you notice that if I take number 1 and number 1 and add them together, I get the number 2. And if I take 1 and 2, add those together, I get the number 3. 2 and 3 add to make 5. 3 and 5 add to make 8. And if I added 5 and 8, the next number would be 13. For number B, I'm multiplying each number by 2. So 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. So each time we just multiply by 2. For this one right here, for number C, letter C, I went up by 2. So the difference from here to here, I went up by 2. From here to here, I went up by 4. From 5 to 13, I went up by 8. And from 13 to 29, I went up by 16. So you see that I'm going up by a number that doubles each time. And then lastly, for letter D, I simply multiply each number by -3. So if I multiply 2 times -3, I get -6. But if I multiply -6 by -3, and negative times negative, positive 18. So I just keep multiplying by -3. So this is our heading for today's lesson. You will want to be taking notes while you're watching this video. So make sure you have your notes. Go ahead and put this as your heading for our notes. These are our objectives, which says the nth term. That nth term just means what term in a sequence. Am I talking about the first term? Am I talking about the third term, the fifth term? And is just what number term I'm talking about, okay? And then rules for sequences is the same thing as like an equation or a formula for a sequence. All right, at this point you need to pause the video and make sure you write each of these things down. And then after you finish writing down, hit play, and I'll talk about a couple of them real quick. All right, sequence is just the set of numbers we're referring to. Term of a sequence is a specific number. So if I have a sequence 2, 3, 5, and then 8, well, the first term is 2, and the fourth term is 8. An infinite sequence is one that goes on forever, like 1, 2, 3, ... Whereas a finite sequence is like the first one I did. It has 2, 3, 5, 8, and then stops. All right, that's it. That's the entire sequence. That's a finite sequence. Okay? Recursive and explicit we'll talk about in just a second, but recursive needs the previous term to make the next set, whereas explicit, I have a formula in terms of just n. Iteration, just something that repeats. This is a pattern, it repeats the same rule over and over again. And a fractal is a picture made by repeating a pattern. We'll talk about that in a little bit too. Okay, so we said recursive is a pattern that depends on the previous term. So for example, if I have a sub n equals 2 a sub n minus 1 plus 1, okay, this is an example of recursive. Now, there's some weird notation in there. We have a sub n. Well, a sub n just means the nth term. So for instance, if I write a sub 1 that means the first term. Okay, and let's say we have a sub 1 equals 5. Well, a sub n minus 1 would be the term before it. So a sub n minus 1 just means the term before a sub n. Now, I want to find a sub 2 and a sub 3. Okay, well, to do that, I'm going to look at my formula. Well, if n is 2, then that means I have 2 a sub 2 minus 1 plus 1. Well, 2 minus 1 is 1, so that's 2 times a sub 1 plus 1. But I know what a sub 1 is. It just says up there that a sub 1 is 5. So 2 times 5 plus 1. 2 times 5 is 10, plus 1 is 11. Same thing for a sub 3. I have 2 times, well, again, n is 3, so 3 minus 1 plus 1. Well, that means 3 minus 1 is 2, so 2 a sub 2 plus 1. A sub 2 we just now found is 11. So 2 times 11 plus 1. 2 times 11 is 22, plus 1 is 23. Okay? And you can try that and find a sub 4, a sub 5, and so on and so forth. And you notice all we're doing is just plugging in the previous term. So to find a sub 4, I would plug a sub 3 in, okay, to find the next term. This is an example of recursive. I just keep using the previous term. Okay. Do one more example. If I say a sub 1 equals negative 5, and a sub n equals a sub n minus 1 minus 8. Okay, well, I'm going to find the first couple of terms, a sub 1, a sub 2, and a sub 3. Well, I already know a sub 1 is negative 5. And then to find a sub 2, well, a sub 2 is a sub 2 minus 1 minus 8. A sub 2 minus 1 is a sub 1 minus 8. A sub 1 is negative 5. Negative 5 minus 8. Negative 5 minus 8 is negative 13. Well, now we're going to find a sub 3. So I'm going to use the negative 13. So a sub 3 minus 1 minus 8 equals a sub 2 minus 8. Again, a sub 2 is negative 13, so negative 13 minus 8. That gives us negative 21. Okay, so again, I just kept using the previous term and plugging it into my formula. So that's an example of a recursive formula. All right. At this point, I want you to pause the video and I want you to try numbers 2, 3, and 4. So I want you to pause the video and try to do numbers 2, 3, and 4 right now. All right, let's do number 4 together. Hopefully you've had a chance to finish 2, 3, and 4. For number 4, I start off with a sub 1, so a sub 1 equals 500. A sub 2 is going to be 500 divided by 5, or 100. A sub 3 is 100 divided by 5, or 20. A sub 4 is 20 divided by 5, or 4. And then lastly, a sub 5 is 4 divided by 5, and as far as it will go. All right, next we have explicit formula. Now explicit formula is actually a little bit easier to use. And the reason why is, with explicit formula, I don't have to use the previous term. So, for example, if I have an explicit formula, would be a sub n equals 2 to the n minus 3. And this time, n is just whatever term I'm trying to find. So if I'm trying to find a sub 1, I just plug 1 in for n. 2 to the 1 minus 3. Well, 2 to the 1 is just 2. And 2 minus 3 is negative 1. If I want to find a sub 2, 2 to the second minus 3. 2 squared is 4 minus 3 equals positive 1. The great thing about explicit, though, is I don't have to necessarily go in order. So I can skip down to a sub 4 and say, well, 2 to the 4th minus 3 equals. Well, I know 2 to the 3rd is 8. 8 times 2 is 16, so 16 minus 3, 13. So whatever term you're trying to find, you just plug that number in for n. You don't need the previous terms. Okay? Try another example of this. A sub n equals n squared minus 2n. And I'm going to find a sub 1, a sub 4, and we'll do a sub 3 as well. Okay, so just find 3 random terms. We don't necessarily have to find them in any particular order. Okay, so if I did a sub 1, well, I'd plug 1 in for n. Well, 1 squared is 1 minus 2 times 1 is 2. A sub 3, I plug 3 in for n. 3 squared is 9 minus 6 equals 3. And then a sub 4, I plug 4 in for n. 4 squared is 16 minus 2 times 4 is 8 equals 8. Okay, so a sub 1, a sub 3, and a sub 4. All right, now I want you to stop the video. I want you to try 3 problems, 5 through 10. So you can just do 5, 6, and 7. Okay, so just those 3 problems. So go ahead and pause the video and attempt those 3 problems. All right, let's look at number 6 together. All right, let's look at number 6. So, a sub 1 is negative 1/2 to the 1 minus 1. Well, 1 minus 1 is 0, and anything to the 0 power is just 1. A sub 2 is negative 1/2. 2 minus 1, negative 1/2 to the 1. Anything to the first power is just itself, so negative 1/2. A sub 3, negative 1/2. 3 minus 1. So that's negative 1/2 squared. Well, if I square a negative, it becomes positive. 1 squared is 1. 2 squared is 4. So positive 1/4. A to the 4th. Four minus 1 is 3. Now I have a negative cube. Well, since my exponent is odd, it's still going to be negative. 1 cubed is 1. 2 cubed is 8. And then lastly, we have a sub 5. So 5 minus 1 is 4. It's an even exponent, so it's going to be positive. 1 to the 4th power is 1, and 2 to the 4th power is 16. So there's my 5 answers. All right, next we're going to talk about how to write rules for sequences. So, if I give you a sequence and say, well, 3, 6, 12, 24, and 48. Okay? Well, if I give you a sequence, I want you to tell me what the rule is. So we're going to write our rules as always as explicit formula. So we're going to write an explicit rule for this one. Well, the first thing is I'm going to do my first, second, third differences and see whether it's a linear, quadratic, cubic, or none of the above. All right. So from 3 to 6, it goes up by 3, 6, 12, 24. And notice those are the same numbers I have in my sequence. Let's try that one more time. 3, 6, 12. And I notice, again, I keep getting the same numbers. And the reason why is, if I keep going, I'm always going to get the same numbers. And I notice that to get my pattern from 3 to 6 is I multiply by 2. From 6 to 12, multiply by 2, 12 to 24. I keep multiplying the previous term by 2. So because of that, this is not an linear or quadratic or cubic function. It's an exponential function because I'm multiplying by the number by the previous term. So how I write my formula is a sub n. Now, whatever number I'm multiplying by is my base. So in this case, I'm multiplying by 2. So I have 2 to the n. We'll start off like that. Now, I'm starting off with the number 3 though. So I'm going to put that in parentheses, and I'm going to put the number I'm starting with out front. So if this works, then I should be able to plug 1 in for n and get my first term. Well, let's see if that works. If I say 3, 2 to the 1, well, 2 to the 1 is just 2. 3 times 2 is 6. Well, that's not my first term. And if I plug 2 in, 3, 2 squared, that's 3 times 4, 12. That's my third term. So I see I'm getting the right terms, but I'm just getting them the term after. I still want to get the first term. So what I need to do is I need to say, well, change my formula. Instead of 2 to the n, I'm going to say 2 to the n minus 1. So what that does is I say, all right, let's try that. A sub 1, well, 3, 2 to the 1 minus 1. Well, 1 minus 1 is 0. 3 times 2 to the 0. Anything to the 0 power is just 1. 3 times 1 is 3. And if I plug in 2, 2 squared is 4 times 3. Sorry, if I plug in 2, 2 minus 1 would be 1. 2 to the 1 is 2 times 3. And I keep getting the rest of those terms. So that is my correct answer. And that may seem a little weird. It takes getting used to. So we'll try a few more. Look at 7. All right, so my first one, again, I'm going to look at my differences. So from 7 to 5, I see I'm going down by 2. 5 to 3, down by 2. 2. So my first difference is all the same. Well, if my first difference is the same, it's linear. So I have a linear problem, okay? So I'm going to write a linear equation. Well, my difference, whatever that common difference is my slope. So I'm going to say that's negative 2 times n. Well, if I plug in 1, a sub 1 equals negative 2 times 1, and I get negative 2 out. But I want to start at 7. So what do I need to add to negative 2 to equal 7? So negative 2 plus what number? We'll say x equals 7. Well, add 2 to both sides. X equals 9. So I'm going to add 9 on the end of my equation. Let's see if that fixes it. Now if I try a sub 1, I get negative 2 times 1 plus 9. Negative 2 times 1 is negative 2 plus 9 equals 7. Let's see if it works for the second one as well. Negative 2 times 2 plus 9. Negative 2 times 2 is negative 4 plus 9 is 5. If you keep trying values, it should work for all of those. So this is my correct formula. So in that case, my formula was just linear. For that second one, you'll see fractions, and that usually freaks you out at first. But that's okay. Some of these are just really just common sense. You just look at it, all right, and don't try to overcomplicate them. For this one, notice that I could rewrite that first term as 1 over 1. And I see my denominators are 1, 2, 3, 4, 5, and so on. So all I have for my a sub n on this one is just a sub n equals 1 over n, because n is just going to be whatever term. If I have a sub 4, which should be 1, 2, 3, this one, I'll have 1 over, plug the 4 in, 4. Okay. So now I want you to try numbers 11, 12, and 13. Go ahead and pause the video now. All right, so if you finish those, number 11 was a sub n equals 3n, because the difference is 3, plus 3. Number 12 was just a sub n equals, so I see the top's going up by 1, so that'd be n, and the bottom is just going to be n plus 1. And then number 13 is we have a slope of negative 10 n plus 35. My slope was negative 10, but in order to get that first term, I needed to add 35. And that should do it for this lesson. Your homework is page 629, numbers 16 through, I believe I said 32. You can ask the sub to make sure. I told her the exact numbers. I believe it was 16 to 32 though. But whatever this homework assignment I gave your sub is correct. Have a good weekend.